All right, so let's introduce translation. So one of the big players in translation is going to be this molecule called transfer RNA. We call it tRNA for short. What you can see is a bunch of different ways that we could represent this molecule. So here's the RNA molecule with the A's, U's, C's, and G's right here. Notice that's kind of complicated. This is even more complicated. Hopefully you can see my mouse here, where we kind of see it's kind of single-stranded. Sometimes it becomes double-stranded. It's still RNA though. So what we can do is, instead of representing it like these two molecules, notice that there's this part called an anticodon here, and then there's like this amino acid attachment site here. We could just simplify and make our molecule like this, where we know it's made out of all the other A's, U's, C's, and G's, but we really just care about this anticodon right here and this amino acid attachment site at the top. Right? We could also look at the simplified molecule like this, where we have this anticodon portion here, the main tRNA molecule, and then the amino acid up on top. All right, so let's look at this in context though. So when you're making a protein, you have your mRNA strand, that's the red strand right here. The brown blob is just your ribosome, and the blue is our tRNA molecule. And notice that the anticodon of the tRNA right here matches with the codon of the mRNA, and the tRNA brings an amino acid with it. So hopefully you can kind of start to see how translation might take place. But let's actually look at an animation of this. So this isn't translation just yet. This is going to be transcription. So this would be happening in the nucleus. Enzyme separates the DNA, and then this enzyme starts to add RNA nucleotides. I know it's RNA because there's a U, and then I also made it red just to show the difference between DNA. Oh, can I show that again? Aha. All right, so we've made our mRNA molecule. DNA zips right back up, and then the mRNA molecule goes out into the cytoplasm to a ribosome. All right, and so notice that here we finally have a ribosome. The ribosome kind of attaches the mRNA like this, and then you're going to notice this chart. Right, this chart we use to figure out which amino acid is going to go with what code on our mRNA molecule. So for instance, notice that I have A, U, G here on my mRNA, and that's going to attach the UAC of my tRNA molecule. But if I want to know, well, what amino acid would be attached here, it's always going to be the same one that goes with this code. So I'm not going to use the anticodon for this chart. I'm going to use the codon, so the AUG, and I'm going to start in the middle of my chart. So in the middle, I have A, U, in the second ring of the circle, and then G. And then notice that G is MET. That stands for methionine. Right? You don't need to know all the names of these amino acids. There's 20 of them, by the way. You just need to know their abbreviations and know how to use the chart. All right. So what's going to happen is, once we have the first tRNA molecule attached right here, then another tRNA molecule is going to come in. Right? And so if we have CCG, then the anticodon on our tRNA would have to be GGC. And that's exactly what we see. And it brings along its own amino acid with it. So again, if I look at my mRNA here, CCG, if we go to our chart, in the middle C, second circle C, G, right? And we get this pro right here. So that stands for proline, right? And now we have two amino acids right next to each other. Now that we have two amino acids next to each other, they can form a bond. So right here we have the very beginning of our protein. We have two amino acids attached together. You know, eventually this protein could be hundreds, thousands even, of amino acids long, but we're not going to worry about showing all of those amino acids. I'm just going to make a 3 amino acid chain here. So then our next codon is U. If I look at my code or my codon chart, I have what would go with U is, or sorry, if I look at my codon chart, it would just be U. And so I'm going to have the amino acid FHE, or phenolphthalein is what that is. All right, so by the way, my anticodon, if this is U, would be AAA, and along with it brings that PHE, that amino acid, or it stands for phenylalanine. Right? And then now that these amino acids are next to each other, another bond is going to form. So notice that once or once our mRNA goes down the line, eventually one of our tRNA molecules just leaves, but my protein is still together right here, right? And then a new tRNA molecule is going to come in, another bond's going to form, right? And eventually, once everything's done, all right, things are going to go down the line, and there's this thing called the stop codon, right? That's UAG. If I look at my chart, UAG, stop, and that tells everything to just go away. So my ribosome's no longer there, my mRNA is no longer there, but I have a protein that is all formed together. All right, so that's how we've just made a protein. We've just done translation. We've just finished protein synthesis.